What's up, players? How you doing? We're in 3.7, talking some ready, some set, and some go. Hope you're having a great day. These problems in the ready give you some throwbacks, working with long division. That's cool. We've done that before, believe it or not, but I'm going to throw you something a little different, how you could approach these with what's called synthetic division. Because I've seen you work with long division in the past, I'm assuming you remember how to do that, but I'm going to show you something that might make your life a little bit easier when dealing with select long division problems. Specifically, if your binomial is x plus or minus some number. And this again being your divisor. So let's take a gander at what's happening. You have this dividend seen here, 5x cubed plus 2x squared minus 45x minus 18. If you're going to follow through with synthetic division, you need a few things. You need to get a hold of the root of your divisor, which opposite of positive 3 is going to be negative 3. You're going to rewrite that little roof that division uses. And instead of writing out the whole dividend, you're just going to use the coefficients in their order with their positive or negative symbols attached. So luckily, this is going x cubed, x squared, x, and then a constant. So we'll do just those. So this is going to save you a lot of time instead of using long division. So what's going to happen here? You're going to drop the first coefficient like it's hot and just rewrite it. And now on the sidelines, you'll think out what's negative 3 times 5. What do you think? Hopefully you're saying negative 15. So you put that there. So now thinking out on this arithmetic here, what's 2 minus 15? Negative 13. Okay, rinse and repeat. What's negative 3 times negative 13? It's 39. What is that? Negative 6. Now think again. Negative 3 times negative 6, that's positive 18. So we get 0. So what's this all mean? This means that we have a remainder of 0. We have a constant in our quotient of negative 6. We have an x term or an x coefficient of negative 13. And then finally, we have a coefficient of 5 when talking about x squared. So what's our final answer for our quotient? It's going to be 5x squared minus 13x minus 6. And you're done. This is your quotient. You did a great job. You have a remainder of 0. And what else is being asked of you here? If p of x equals this, what's the value of negative 3? Interestingly enough, you just did that. It's going to be 0. So why is this helpful? You just knocked out 2 problems in one, really, if you really think on it. You did the long division, even though you used, again, called synthetic division. You actually are doing this plug-in of negative 3 here, believe it or not. And you're getting your outcome of what that p of negative 3 is. It's 0. How does this work? It's a complex explanation. Come to learn if you want to learn more, or shoot me an email. But trust it, because it works, and it's pretty great. 2 is going to be simple. 3 is simple. 4 is simple. I say those are simple because they are not missing a beat. They have each term that you would need. I guess the one thing that may come up down the road is if you have a dividend of like 3x squared plus 5, then you would want to just use coefficients of 3, 0, and then 5 because your x term is MIA. So put in 0 as a placeholder if you decide to proceed with synthetic division, which I hope you do, because I think it's a good time. It's pretty simple. Our set has us predicting the number of roots, then using the graph to help you write the polynomial in factor form. This is super simple. You could factor this like you normally do, or you could say that you have a root where x is 2, and also a root where x is -5. Based off of what we worked on in the classwork, we could say that our factored form is really just taking x minus our roots and x minus your other roots. So you may have one root or two roots, you may have more, but you can follow through with this if you'd like. So our first root on the left is -5, so x minus -5. We'll put a pin in that, we'll talk more about it. And then our other binomial is x minus 2 because of this 2. X minus -5 can be rewritten to this. And so, boom, we've got our factored form. But remember, fall back on factoring if you need to, because you could have easily done this. Factors of -10 that add up to 3, it's 5 and -2. So you could have used basic factoring here, but you can also use the visual, okay? So here you have 3 roots. You have one at -3. You have another root where x is -1, even though it says 0. And you also have a root where x is 3. So let's do this. You could say it's x minus -3 in one binomial, multiplying with x minus -1 in another binomial, and another one, x minus 3 here. Take a moment, pause the video, try to clean this up. What will this look like when you get rid of this minus negative nonsense? So hopefully you got something like this: x plus 3, x plus 1, x minus 3. You may be curious if this is going to get you back to this polynomial. So one way that you could check your work is by foiling. Stop foiling around. So you could check by foiling or box it out and see if it matches this polynomial that is here. Simple enough, right? Let's keep this going. 7 may not look like much, but there is definitely a root where x is -2. And so if you look at this closely, what's common between these two terms, -2x and -4? Hopefully you're saying that -2 could be factored out. Leave you with this. So this kind of makes sense that x minus our root of -2 will leave us a binomial like this. -2, you might have not seen that coming, but it is there. So there you go. So there's one real root there. Here, you can do a mix of things to solve this. You could do some root counting and say that there's going to be 4 here, respectively. You could also do some factoring by grouping if you were so inclined, and say that you can factor out x cubed minus 1, and you can probably get away with that here, and say that -4 can be factored out. Sorry, -4x. So then you could really say that this is x cubed minus 4x, multiplying with x minus 1. And you might be saying, well, Cortez, there are 4 roots. Where are those 4 binomials, or where's the multiplicity? Well, this is taken care of because it talked about where x is 1. Can this be taken further? Sure can. It's x squared minus 4. And then if you see this and think, oh, that's difference of squares, I can rewrite that also. Then kudos to you, because you're right. It's x minus 2 and x plus 2, sandwiched in between x minus 1 and x. Capiche? Again, foil it back out if you're not convinced that it's going to work, but this should work. These are boring to me. Let's try something that it's a little bit more challenging. Here, you could factor out -1, leave x squared minus 6x plus 9. This is a trinomial that can be factored further to -1, x minus 3, with multiplicity of 2. Well, there it is. Whoop, there it is. Multiplicity of 2. And how is this there? Like, how does this work? Well, it goes up, it hits it like a vertex, then bounces back down. And we say that with the fundamental theorem, we would assume with an exponent, highest exponent of 2, we would have 2 roots. And even though we only have 1 root here, the multiplicity of 2 saves it. So this works out pretty well. So in this case, there is a root where x equals 3, and you would say that there's multiplicity of 2. Capiche? Sound good? Whoa, 10. Bringing in the big guns here. What do you think you could factor out from these 3 terms? Anything? Well, they have x squared kind of hidden in all of them. So I would hope that you can pop back in, say x squared's factored out, leaving you x to the 4th minus 5x squared plus 4. Does that all make sense? I hope it does. And then this you can actually factor further, because really they're just saying that it's x squared times x squared is your leading terms in this binomial, minus 1, and then minus 4, because factors of 4 that add up to -5 or -1 and -4 respectively. Try it if you don't think it works. You're then going to hit a little bit of difference of squares here. You get x plus 1. And you guessed it, x minus 1. You will also get x plus dose and x minus dose. And you also have your x's out here. And I should note that this is going to be multiplicity of 2, where x is 0, which makes sense because doesn't this bounce back like a quadratic the way that it did here? So this would be your factored form. Key ingredient is that there's multiplicity of 2 when x is 0. Hope that helps. Those are nice problems. You should very much understand what was happening. All right, find your roots. Simple enough. Here, I'll leave it to you. Factors of 51 that add up to 20, if any. Is that possible? I'll leave it up to you. I think it's, what is it, 3 and 17? So I'll leave that for you. This can definitely be taken further with factoring. This is really just a binomial being squared for what it's worth. So I will leave that to you. 14. Is there anything common between these 2 terms? Hopefully you're saying 3x can be factored out, leaving you x plus 4. So set these equal to 0. This part, at this point, if you're still writing out this work, cool. But I would hope that at some point you just know like, oh, okay, x is a factor, so x equals 0, that's a root. And also x equals -4 is another root. Capiche? Some difference of squares here in disguise. X times x will definitely get you x squared. Your middle term needs to cancel, so you need minus and then plus. Square root of 11 is just square root of 11. So here, your roots are going to be respectively plus or minus root 11. So again, the Go is asking you what are the roots, not what is it factored. So kick it up a notch, take it further. Here, you're going to use quadratic formula. I will leave you a little bit of that work. X equals -b plus or minus square root b squared minus 4ac all over dose a, just 2 times 1. You will be able to get a set of two real roots here. So I will leave this to you to find what x is going to be. And this, I think you're also probably going to have to do quadratic formula. And I think that's good enough. That was a lot of work, right? I hope that this was helpful. If you get stuck, talk to me, send me an email, do something to help me help you. Thanks for watching. Take care. Brush your hair.